Hi dear students, welcome to this discussion of previous question papers of JEE Advanced from Eigenlearning. So let us take a question from JEE Advanced 2022 paper 2. It's a question in organic chemistry. Seems rather very simple. The question is integer type question where you have to find the number of methylene groups, CH2 groups in the product formed from the following reaction sequence. So there's just one starting compound which is a hydrocarbon containing 8 carbon atoms with a double bond at the middle. Okay, so the compound is 1, 2, 3, 4. So it will be oct. 4 plus 4, 8 means octane, and if it is double bond, it is octene. So the compound is 1, 2, 3, 4. Oct-4-ene is a compound. Oct-4-ene is a compound. Okay, and then this compound is subjected to a series of reactions. And what are the reactions one by one? It is ozonolysis. The first reaction is ozone, followed by treatment with the zinc dust and water. The two things together means ozonolysis reaction. And you know that in ozonolysis, the products can be easily written. The products can be easily written, okay, just by splitting the molecule at the double bond and putting an oxygen here and one oxygen here. So that is the total outcome of ozonolysis. An easy way of predicting what are the products in ozonolysis. So here you have CH3, CH2, CH2, CHO, and here also you have CH3, CH2, CH2, CHO. So during ozonolysis, during the reaction number 1, you get the 2 molecules of CH3, CH2, CH2, CHO. That means you get 2 molecules of butanol. An aldehyde is a product of ozonolysis in this case. And now the second reaction is oxidation by potassium permanganate. It's an aldehyde. So the reaction is pretty simple. Oxidation by potassium permanganate will convert the compound into an acid. So you have the carboxylic acid as a product, right? And now this compound is in the third step, reaction with the NaOH, you get the salt of the acid, isn't it? The salt of the acid, CO minus Na plus. And this compound is subjected to electrolysis. And this electrolysis is what you call the Kolb's electrolysis, isn't it? The electrolysis of sodium or potassium salt of a carboxylic acid. And the method is important as it gives you a method of preparing an alkane, a symmetrical alkane. In this case, an alkane, by joining these 2 groups, actually when it is electrolyzed, it will ionize CO minus Na plus, and then it will undergo decarboxylation to give CH3, CH2, CH2 radical plus an electron, and this radical will combine, 2 such radicals will combine to give the compound CH3, CH2, CH2, okay, CH2, CH2, CH3. So what you get is normal hexane as a product of Kolb's electrolysis of this compound. This compound is butanoic acid. So this is sodium butanoate, and sodium butanoate on electrolysis gives, in aqueous solution, gives normal hexane, the hydrocarbon. Okay? And the last step of the reaction is the reaction with the catalytic compound, Cr2O3, chromium oxide catalyst at a temperature of something like 770 Kelvin and 20 atmosphere. And what is the most probable reaction here? In the presence of the catalyst at a somewhat very high temperature, and comparatively high pressure, what actually happens in the case of straight chain alkane is a cyclization followed by dehydrogenation. Now, this is something that is studied in alkane chemistry under the influence of certain special catalysts, the straight chain alkanes. So, for example, those containing 6 carbon atoms or 7 carbon atoms, those containing 6 carbon atoms undergo cyclization to form cyclohexane, and this cyclohexane, again under the influence of the same catalyst at the temperature pressure condition, undergoes dehydrogenation. So cyclization followed by dehydrogenation gives the compound benzene. Okay, what you get is a 6 carbon cyclic compound. Initially it is cyclohexane, but the cyclohexane undergoes dehydrogenation in the presence of this catalyst, chromic oxide catalyst at this temperature pressure condition to give the compound benzene, and this reaction very often called aromatization. So there is cyclization, there is dehydrogenation, and the net result is aromatization to give a very stable compound benzene. And we know that in benzene there are 6 CH groups, alternate double and single bonds. There are no CH2 groups at all. So what is the answer to the question? The number of CH2 groups. That's the question. So what's the number of CH2 groups? The number of CH2 groups is 0. So the answer of the question is 0. No CH2 groups in the final product. The final product, the number of CH2 groups is 0. So the answer is 0. I hope it is clear. Okay. When you see the question, you may be tempted to write cyclohexane, 6 CH2 groups. But that is wrong. It is cyclohexane further undergoing dehydrogenation to give benzene in the presence of this particular catalyst, chromic oxide, under this temperature pressure condition. And therefore the final product is benzene. It doesn't contain any CH2 groups, and therefore the number of CH2 groups in the final product is 0. Okay? The question is pretty simple, but towards the end you have to be a little bit careful. A question based on alkane chemistry. Okay? You have cyclization, dehydrogenation, aromatization to give benzene as the final product. Fine?